Assalamu alaikum. Hello students. Welcome to my channel Nisa Academy. First of all, a very thank you for visiting my channel. A brief introduction about myself. My name is Shana Sheikh and I have completed my masters in mathematics. I've been teaching mathematics for the last 6 years for different classes. Okay, so in my channel here I will be uploading mathematics from class 9th to class 12th. So today, to begin with, I'll be solving for you the model question paper of mathematics level 1 for Goa board. Now since last year, the Goa board paper pattern, the board exam pattern has been changed. As you know, there are two board exams. The first is the multiple choice and the second is the subjective. So mostly students are struggling with the MCQ based questions. So I will try to solve as many sample papers as I can. But if you have any doubts or any queries, or if you want to solve any particular chapter or any particular sample paper, then you can even join my online coaching classes. Okay, for that you can either mail or DM us on Instagram. Both the links I have mentioned in the description box. So hopefully you will like this video. So please share as much as you can with your friends. I hope this video really helps you in your board exams. So let's begin. So the Goa Board of Secondary and Higher Secondary Education first term examination model paper, mathematics level 1, marks 40, time is 1 hour 45 minutes. So you will be given 4 choices and here to select the correct choice. Also, there is no negative marking. Okay. So let's begin. The first question. The prime factorization of 1176 is. Prime factorization means we have to find the prime factors. So let's start. 1176. Okay. We'll start with 2. 2 5s are 10. 1 remains. 2 8s are 16. Again 1 remains. 2 8s are 16. Then 2 2s are 4. 1 remains. 2 9s are 18, 2 4s are 8. Let's go on. 2 1s are 2, 2 4s are 8, 1 remains, 2 7s are 14. Further, we cannot divide by 2. So, we'll go for 3. 3 4s are 12, 2 remains, 3 9s are 27. And we know this is 7 7s are 49, 7 1s are 7. So, can I write it as 2 cube into 3 into 7 square? Yes. And see which option matches? Yes, the D option. Okay, so the correct choice is D. Hope you understood. Let's go for the next problem. If the lines given by 4x plus ky equal to 12 and x plus 2y equal to 3 coincide, then the value of k is. Okay, now given equations of two lines. a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. We know there are three conditions, that is for intersecting lines, parallel lines and coincident line. So what is the condition for coincident line? It is a1 upon a2 equal to b1 upon b2 equal to c1 upon c2, right? So means the lines coincide, that is they have infinitely many solutions, right? So let's write the equations. 4x plus ky equal to 12 and x plus 2y equal to 3. Let's compare. a1 is 4, b1 is k, c1 is 12. Here a2 is 1, b2 is 2, c2 is 3. I guess we only need a1, a2, b1, b2. So we can find the value of k. So a1 is 4, a2 is 1, b1 is k, a2 is 2. So what is the value of k? Therefore k is equal to 4 2s are 8. Okay, let's see which option. Yes, option C. Yes, hope you understood. So you have to study the three conditions, okay, for different, for intersecting lines, parallel lines and coincident lines. So let's go for the next problem. The third problem. If 1 plus 10 square 36 is equal to secant square 2a, where 2a is an acute angle, then the value of A is. Now, we know the identity 1 plus tan square theta is equal to secant square theta. Okay, so can I write 1 plus tan square 36 equal to secant square 36? So I will write the equation which is given to me. So 1 plus tan square 36 is equal to secant square 2a. I will substitute the value of 1 plus tan square 36 over here. So secant square 36 degree equal to secant square 2a. Secant square gets cancelled. 36 degree equal to 2a. So what is a? 36 by 2, which is 2 ones are 2 eights are. So 18 degree. So see, yes, the first option. Okay, so this is how you solve it. Let's go for the next problem. The midpoint of the line segment joining the points P minus 3, 4 and Q 7 minus 2 is, so this is a line segment P and the point Q. Okay, and you have to find the midpoint. Say R. So I will write minus 3, 4, 7 minus 2. So what is the midpoint formula? This is problem from your coordinate geometry, and we have studied section formula, midpoint formula, right? So it divides exactly into 1:1 ratio. So the midpoint formula is what? We get it from the section formula only. So x1 plus x2 by 2 and y1 plus y2 by 2, right? So I will write this as x1 y1 and this as x2 y2. So let's write what is x1? Minus 3 plus 7 by 2. And what is y1? 4 plus y2 is minus 2 by 2. So minus 3 plus 7 is 4 by 2. And this is 4 minus 2 is 2 by 2. Okay. So which is 2 and 1. Right. So the correct option is 2, 1. So option number D. Okay. Hope you understood. Fifth question. One of the zeros of the quadratic polynomial 4x square minus 25 is. Okay. So we know that any number A is a zero of polynomial p of x if what? If I put a in the polynomial, the value of the polynomial will become 0, right? So now we have to find the zeros of the quadratic, means obviously it will have two roots, yeah? So we have to find one of the root or one of the zero, okay? So solving, that is finding the zero of a polynomial is same as solving this equation, right? P of x equal to 0. So can I say 4x square minus 25 equal to 0, right? Therefore, 4x square equal to 25. So, x square is equal to 25 upon 4. Therefore, x is what? I have to take the square root, which is plus or minus 2 roots, na? So, 5 by 2. Okay, so one of them you have to find. So, see, plus 5 by 2 and minus 5 by 2. So, which is given to us in the option plus 5 by 2. So, that is the answer. Okay. Yes, understood? Okay, let's go for the next problem. From a deck of 52 playing cards, all the ace cards are removed. If a card is then drawn at random, the probability that it is a face card is. Now, you know the distribution of playing cards, right? So, in 52 playing cards, you know, they are divided into 26 what? Red cards, correct? And 26 black cards, right? Further, these are 26, they are divided into 4 suits, right? 4 suits, where each suit has 13 cards, right? Each suit has 13 cards. And what are they? That is king, queen, jack, okay? And the ace card, as well as 2 to 10, the number cards, right? In each of the suits. So basically, if you see here, these are called, this king, queen and jack are called the face cards, right? So there are in total 1, 1, 1 in each. How many suits are there? 4, right? So how many total? 3 in one suit. So 4 suits means 3 fours are 12. So there are 12 face cards. Okay, and how many ace cards? 4 ace cards. Okay, one in each. Now let's see the question. So from a deck of 52 playing cards, all the ace cards are removed. Okay. So first the total 52. How many ace cards are removed? So 4. So the total possible outcomes is what? 48. Yes. And the next part, if a card is then drawn at random, the probability that it is a face card is. Okay. Now see, what is the how many face cards are there? 12 face cards. So what is the probability of any event number of favorable outcomes upon total possible outcomes? So favorable means what? The face cards, and the total possible outcomes is 48, right? So 12 ones are, 12 fours are, which is 1 upon 4. So the answer is option A, 1 upon 4. Okay, understood? So the next problem, the length of the tangent drawn from a point P, which is at a distance of 7 cm from the center O of a circle of radius 3 cm is. So you can see here, this is a circle of radius 3 cm. P is a point which is at a distance of 7 cm from the center O, that is OP7, and you have to find the value of AP, which is the tangent. Okay, and we know what is a tangent. Tangent is a line which intersects the circle at exactly one point. Also we know that a tangent and a radius are what? Perpendicular to each other, right? That is the theorem 10.1. You can check in your NCERT book. So what we can use, this is a right angle triangle, so we can use the Pythagoras theorem. So in triangle OAP by Pythagoras theorem, so see here OP is the hypotenuse, so OP square is equal to OA square plus AP square. Okay, we write here by Pythagoras theorem. So OP is 7 square, OA is 3 square, AP we are supposed to find. So 49 is equal to 9 plus AP square. So 49 minus 9. So AP square is equal to, can I have, it is 40. So what is AP? It is root 40. Okay. So if you check here, we don't have the option of root 40. Don't worry, we can, further we are supposed to solve this. So root 40, so can I write it as 10 into 4? Okay, see, whenever you have this type of where you don't have a perfect square, but you can write in such a, split the number in such a way that one of them is a perfect square and another one is not. Okay, so 40 I can write 22s also, but both 2 and 20 are not a perfect square, right? So that's why I'm writing 10 into 4. Why? Because 4 is a perfect square. So square root of 4 is 2 and this is 2 root 10. So AP is 2 root 10. Now let's see whether we have the option. Yes, we have the option 2 root 10 centimeter. Option A. Okay, understood? Next problem. The length of the arc of a circle of radius r and angle with degree major theta is. Yes, that is a direct formula. You know what is it? Length of arc of a circle. What is the formula? It is theta upon 360 into 2 pi r. But we don't have the option over here. So what? Just divide this 360 by 2, which is 180. So theta upon 180 into pi r. So see option A. Okay. Ninth problem. Which of the following is irrational number? What is an irrational number? Which you cannot write in the form of P upon Q, which is not rational. Okay. So let's go through the options one by one. First option, A, root of 729. Okay, let's find. Let's see whether we can find. So 2, you cannot start with 2. Yes, it will not be divisible by 2. So let's start with 3. 3 2s are 6. 3 4s are 12. 3 3s are 9. Then again 3 8s are 24. 3 1s are 3. Just go on with 3. 3 2s are 6. 2 remains. 3 7s are 21. This is 3 9s are, 3 3s are, and 3 1s are. Okay. So 1 from each pair. 3 into 3 into 3, which is 27, which is a rational number, right? So the first option is not the answer. Let's go for the second option. Root 3 minus 2 into root 3 plus 2. Okay, you see the second option here. So do you remember something? Yes, a minus b, a plus b. What is it? A square minus b square. So can I write it as root 3 square minus 2 square? Yes, the root 3 square is 3 minus 2 square is 4, which is minus 1. Again, a rational number. Okay, so let's go for the third option. 3 plus 2 root 3 by root 3. So let's multiply both the numerator, that is rationalize denominator. Okay, so multiply both the numerator and denominator by root 3. So root 3 upon 3 into 2 plus root 3, and this is root 3 into root 3, which is 3. So when I multiply this, this is 3 root 3 plus 2 root 3 into root 3 is 2 3s are 6 upon 3. And we have studied in 9th and even now in 10th that the product or a quotient of a rational by irrational is always what? An irrational number. Okay, so we know that this quotient is will always be an irrational number. So the answer is C. Okay. Yes. Even if you check the C, the D option, you will get the rational number only, because root 2 into root 2 is 2 and root 2 into root 8 is root 16, which is 4. So 2 minus 4 again minus 2, which is a rational number. Okay. 10th problem. If one equation of a pair of consistent linear equation is 3x minus 2y plus 4 equal to 0, then the second equation can be. So we know the condition of consistent linear equation. What is the condition? Yes, it is a1 upon a2 not equal to b1 upon b2. Means the lines are intersecting. They have exactly one solution. Dependent consistent means lines are coincident, right? And parallel lines inconsistent. So let's see, go through the options one by one, and let's check which of the following equation given to us options satisfy this condition. So our equation given to us is 3x minus 2y plus 4 equal to 0. A1 is 3, B1 is minus 2. Okay, so the first option. 6x minus 4y plus 1 equal to 0. So A2 will be 6, right, A2 is 6 and B2 is minus 4. Okay, so let's check A1 upon A2. You can see here 3 by 6, which is 1 by 2, and B1 upon B2 minus 2 by minus 4, which is again 1 by 2. So no, this the first equation does not satisfy our condition. Okay, so let's go for the second equation. Minus 6x plus 4y plus 1 equal to 0. A2 will be minus 6 here, B2 will be 4. Again let's check. 3 by minus 6 is minus 1 upon 2 and B2 is minus 2 by 4, which is minus 1 upon 2. So again this equation is not the solution. Okay, let's go for the third. 6x plus 4y plus 1 equal to 0. A2 is again 6, B2 is 4. Okay, so 3 by 6, which is 1 by 2, and B1 is minus 2 by 4, which is minus 1 by 2. In this case, A1 upon A2 is not equal to B1 upon B2. Okay, so that means the equation 6x plus 4y plus 1 equal to 0 satisfies a condition A1 upon A2 not equal to B1 upon B2. So the correct option is C. Understood? So you have to remember all the three conditions. Okay. Next problem. If triangle PQR is right angle at P and Q equal to 60 degree, then the value of cos R is. So, triangle PQR, okay, PQR, right angle at P, so P is 90, Q is given to us as 60 and we have to find the value of cos R. So, we know angle P plus angle Q plus angle R, sum of the angles of a triangle is 180. So, P is 90, Q is 60, R we don't know, which is 180. So, this is 150. So, 180 minus 150, which is 30. Okay, you can even guess and don't have to actually do this. Just by looking also you can tell this is 90, 60, so obviously it will be 30. Okay, so we have to find cos R, so which is cos 30, right? And it is root 3 by 2. Cos 30 is root 3 by 2. Trigonometric angles. So yes, that is the option D. Okay. 12th question. The perimeter of a triangle with vertices A06, B00, C minus 80 is. So, a triangle, okay, ABC. A is 06, this is 00 and C is minus 80. So, we have to find the perimeter of a triangle. So, what is a perimeter? Okay, perimeter of a triangle. Yes, it is AB plus BC plus AC, right? That is the perimeter of a triangle. So, what we have to find? We have to find AB, BC and AC. So, how we find it? They are the coordinates, right? So, coordinate geometry, yes, distance formula. So, AB equal to, what is the distance formula? X2 minus X1 whole square plus Y2 minus Y1 whole square, correct? And even you can write x1 minus x2 square because you are squaring, right? So, it does not matter. So, now let us say this is x1 y1 and this is x2 y2, okay. So, x2 minus x1, which is 0, I can just directly write her, and y2 you can see 0 minus 6, so minus 6 square, so which is 0 plus 6 square is 36 again, and the square root is 6. Next, BC will find, okay. So, if you see BC, this we can take this as x1 y1 now. So, 0 minus of minus 8, which is 8 square, and that is 0 square, so which is 64. So, square root of 64 is 8. And the last is AC. So, can I take, okay, we will take this as x2 y2 over here. So, x2, so 0 minus of minus, which is 8 square, plus 6 minus 0, which is 6 square. So, which is 64 plus 36, which is square root of 100, which is 10. So, now just add this 6 plus 8 plus 10, which is 24, right? AB plus BC plus AC, 24. So, let us check. Yes, option C, 24 units. Okay, that is the answer. Hope you understood. Yes. Let's go for the next problem. If the product of the zeros of the quadratic polynomial 5x square minus 20x minus m is 3, then the value of m is. Yes, we know if alpha and beta are the zeros, okay, are the zeros of a polynomial, then alpha plus beta is minus b upon a, that is sum of the zeros, and alpha into beta is c upon a, that is product of the zeros, okay. So, now in 5x square minus 20x minus m, let us compare. A is 5, B is minus 20 and C is minus m. So, we are given that product of the zeros, okay. So, alpha into beta is c upon a, which is minus m upon a, which is 5. And what is alpha into beta given to us? Yes, 3 is equal to minus m upon 5. Therefore, m is equal to 3 5s and minus sign. So, m is equal to minus 15. So let's see. Yes, option number A. Okay, so the answer is minus 50. Understood? Product of the zeros. Next problem. A box contains cards which are numbered from 5 to 102. If a card is drawn at random from the box, then the probability that it bears a 2-digit number which is a multiple of 7 is. Okay, so see, they are numbered from 5 to 102. So total number of cards, now most of the students will make a mistake here. They will say there are 97 cards. Okay, that is the mistake they will do. But no. Now just imagine there are numbers from 1, okay, 2, 3, 4, 5 onwards till 100, okay, then 101 and 102. Just imagine there are numbers, okay, from 1 to 100, 102. So you are considering from 5 to 102, right? So obviously you won't take this 4. So now from this 100, if I consider this only 100 numbers, if I subtract this 4, so how many are there? 96 total. Okay, from this 4, if I subtract from 100, so 96 numbers plus this 2, 101 and 102. So total how many numbers are there? Yes, there are 98. Okay, so not 97. If you take 97, it means you are not considering 5, but they have mentioned here a box contains cards which are numbered from 5 onwards, right? 5 to 102 you are considering. So that's why it's very important to take properly the numbers, okay, to find the total possible outcomes. Okay. So the total possible outcomes are 98. Okay, and next, see, if a card is drawn at random, then the probability that it bears a 2-digit number which is a multiple of 7. Okay, so just let's write the table of 7, but 2 digits, so we cannot take 7, so start from 14. Okay, 7 3s are 21, 7 4s are 28, 7 5s are 35, 7 6s are 42, 7 7s are 49, 7 8s are 56, 7 9s are 63, 7 10s are 70, 7 11s are 77, 12 sevens are 84, 13 sevens are 91, 14 sevens are 98, but 15 sevens is what? More than 102. We cannot take that because the numbers are till 102, right? So these are let's just count this: 1 2 3 4 5 6 7 8 9 10 11 12 13, right? So probability of that event will be what? Favorable outcomes are 13 upon total possible outcomes are 98. So the option A. Okay, so this is a final answer for the 14th question. Yes, so please be careful in this type of questions. Okay, 15th problem. In the figure, MA and MB are tangents to the circle with center O and radius 5 centimeter. So this radius is 5 centimeter. Okay, and if OM is 13 centimeter, so OM, okay, is 13 centimeter, perimeter of quadrilateral AOBM is. So what I'm supposed to find? Yes, the perimeter. So I need to find just this two tangents, okay, and this I already have, that is OA, and just I need to add them, the 4 parts, right? OA, OB, BM and OM. And we know the tangents from an external point to a circle are equal, right? So AM will be equal to BM. So I just need to find any one tangent, right? And also we know that this AM is perpendicular to OA. Radius is perpendicular to a tangent. So same like the previous problem, we have to take a right angle triangle, Pythagoras theorem. Let's find AM. So in triangle OAM, okay, OA square plus AM square is equal to OM square. Okay, so what is OA? Given to us 5, AM we are supposed to find. OM is 13 square. So AM square is 13 square is 169, 5 square is 25. So which is 144 AM square. So what is AM? Square root of 144, which is 12. So this is 12, this is also 12, right? So now just add this. So OA plus OB plus AM equal to what is that? BM plus BM, or MB you can also write. That is the perimeter. Okay, perimeter of quadrilateral AOBM. So let's just add. So 5 plus 5 plus 12 plus 12. Okay, so 10 plus 24, which is 34 centimeters. So let's see. Yes, option C. Yes, understood? Next problem. 16th problem. Quadrilateral ABCD is a rectangle. If AB equal to 5 centimeter and radius of the semicircle AM equal to 7 centimeter, then area of the shaded portion is. Okay. Now let's just talk about the semicircle. Okay. So in the semicircle, here is the circle, right? This is AMD. AM is 7, that is the radius, so MD is also 7 centimeter. Okay, now if I want to find the area of this part, so this is the shaded part, right? I want to find the area of the shaded part, which are marked in blue. So if I want to find the area of the shaded portion, what I'm supposed to do? Yes, I will find the area of the semicircle and I will subtract the area of this circle, right? Area of the circle. So if I subtract the area of the circle from the area of the semicircle, what I will get? Exactly the area of the shaded part, right? From the whole semicircle, okay, area of the semicircle, if I subtract the area of this circle, so what I will get is the shaded portion, the blue portion, right? So let's just first find area of circle. So what is the formula? Pi r square. But we don't have r here. Yes. So see carefully, this is the circle. Now this whole, this is the diameter of the circle. But actually it is the radius of the semicircle. Yes. Is it the radius of the semicircle? Yes, it is. So how much it is given to us? 7, right? And it's the diameter of the circle. So diameter of the circle is 7. So radius will be 7 by 2, which is 3.5. Okay. So now just put the value, which is 3.5 square. So 22 by 7, can I just write this as 3.5 into 3.5? Okay. Much better, I will convert into fractions, okay, into 10, 35 by 10. So 7 5s are, 5 2s are, 2 11s are. So 11 into 35 is 385 by 10. So 38.5 centimeter square. Okay. Now next, let's find area of semicircle. So area of circle is pi r square. So semi means half. So it is half into pi r square. So half into 22 by 7. R is what? Yes, 7 into 7. 7 7 to 11s are. So 77 centimeter square. Okay. So what will be the area of the shaded part? Area of shaded portion. Only of the semicircle I am talking about. It will be area of the semicircle minus this 38.5 area of the circle, which will be equal to 38.5 centimeter square. Okay, so first part, this one portion is done. Now let's talk about the triangle. So see here. So this is the rectangle, and this part we are supposed to find. So we have to find the shaded part, that is the area of the triangle, right? So now this is given to us that this is a rectangle, and see here carefully. Okay, this is AM is 7, this MD is 7, so this total AD, okay, this AD is how much? 7 plus 7, 14, right? So I will just write here this AD, okay, and next what I have to write? AD and BC, okay. So ABCD, right? So this AD we know it's 14. So obviously BC will be 14, opposite sides of a rectangle, right? So we have got the base. Now what about the height? So let's just draw a perpendicular height. Okay. So this is the height of the triangle. So if you see here, AB is given to us 5 centimeter. So this height and the breadth of the rectangle are exactly same, right? So if this is 5, can I write this as 5? Yes, it is 5. Okay. So area of triangle equal to half into base into height. So half into base is what? 14. Height is 5. So 2 sevens are, so which is 35. Correct? So now we have to find a total shaded, we have to find a shaded means the total shaded part. Okay? So that is what I will just add those two. So 38.5. So the total shaded portion, which will be equal to 38.5 plus 35. So which is equal to 73.5, okay, centimeter square. So let's see, yes, the option B. Yes, understood? Okay. 17th problem, which of the following rational numbers has a terminating decimal expansion? Okay, in 9th standard we used to actually do the division and check whether the number has a terminating or non-terminating, but now you don't have to do that. Okay, so the first thing you are going to check is, if given a rational number P upon Q, first thing is you have to check whether P and Q are co-prime. Okay, so what do you mean by co-prime numbers? Yes, which has a HCF equal to 1. For example, 3 and 5. Okay, what are the factors of 3? 1 and 3. And what are the factors of 5? 1, 5. So which is the highest common factor here? Only 1, right? So such numbers are called co-prime numbers. So first thing you have to check that whether P and Q are co-prime in that. Okay, and next thing is that, so this is the first thing. Then second, what you will check is the denominator. Okay, the Q. So if the denominator is of the form 2 raised to n 5 raised to m, then you can say that the rational number has a terminating decimal expansion. Now what it means actually, see here, if suppose this is a number 7 by 20, can I write this as 7 upon, see the factors of 20, so it is 2 square into 5. Yes, 5 raised to, I will say 1. So see here, the denominator is in the form 2 raised to n into 5 raised to m. So I don't have to do the actual division. Just by looking at the number 7 by 20, I can say that yes, it has a terminating decimal expansion. Okay. Now what about, suppose another number I will take. What about this number? 7 upon 5. So yes, it also has a terminating decimal expansion. Okay, or I can say 5 by 8. So can I write this as 5 upon 2 cube? Yes, so this number will also has terminating decimal expansion. Okay, so either it should be in the form like product of 2 and 5, 2 to the power something into 5 to the power, okay, or just the power of 5 or just the power of 2. In all these cases it will have the decimal expansion of the number will be terminating. Okay, but if you have suppose any number of this form, say 8 upon 2 cube into 5 into 3, in this case, the number will not have a terminating, it will be non-terminating. Okay. So other than this 2 and 3, 2 and 5, if you have some other number, okay, that is 3 or any other apart from this, then definitely the expansion will have non-terminating. Okay, expansion will be non-terminating. So either you should have this in this form 2 raised to n, or you can have just 5, that is a power of 5 or power of 2. In all these three cases you will find that the expansion is terminating. Okay, so let's just check the options. So first option, you can see 12. How you can factorize it? Yes, 12, 2 2s are 4, right? So it is, see here, it is, I will just write here 2 square into 3. So see here, apart from 2 you are getting 2 and 5, you are getting this 3, right? So no, option A is not the correct. Then what about 45? Yes, then again 5 square is into 3, 9 5s are, so into 3 you are getting no. Okay, now 27 by 72, first as I told you, you have to check whether they are in the first two cases they were already co-prime, but here 27 by 72 I will first reduce it. Okay, so 3 9s are 27, 3 2s are 6, 3 4s are 12, then 3 3s are 9, 3 8s are 24. Okay, so now the number is in the co-prime. Okay, so can I write this as 2 cube? Yes, in the power of 2. So I just now I told you, right? If it is the just power of 2 or the power of 5 or let's product of both, then the number has a terminating decimal expansion. So the answer is C, 27 by 72. Okay, so first thing you have to do is, if the number is in the not in the reduced form, okay, make it, make the number co-prime. Okay, bring it to the reduced form, and then just check the denominator. So this is how you solve. Okay. 18th problem, the solution of the pair of linear equations 8x minus 3y equal to minus 2 and 3x plus y equal to minus 5 is. So you have studied different methods to solve this equations, which is elimination method, substitution method, cross multiplication method, right? So you can choose any of that, or the other way is like substituting the this options one by one in the equations. Okay, and check which of the this option satisfy your equations. Okay, so I will choose the first, that is I will take any one of the method. Let's go for elimination. Okay, so 8x minus 3y equal to minus 2, this is my equation number 1, and 3x plus y equal to minus 5, equation number 2. So I choose to eliminate y. You can eliminate x also, whichever you want to. So I choose to eliminate y, so I will multiply equation 2 by 3. Okay, so multiplying equation 2 by 3, so what I will get is 9x plus 3y equal to minus 15. Correct? So let's just add equation 1 and 3. Okay, adding equation 1 and 3. So 8x minus 3y equal to minus 2, 9x plus 3y equal to minus 15. So 8 plus 9 is 17x, that cancel, equal to minus 17. Okay, so x is minus 17 by 17, which is equal to minus 1. Okay, x equal to minus 1. Now let's just see the options. Okay, so yeah, there are two options which say x equal to minus 1, and here also see x equal to minus 1, y equal to minus 2. So I need to find the value of y. Otherwise what happens is sometimes you have all the options are different, so you have only one of the options, suppose x equal to where minus 1 and y equal to something, then you can just mark that. Okay, but make sure that your value of x is correct. Okay, so yes, let's find. I will substitute in equation, any of the equation you can substitute. I will put in equation number 2. Okay, so which is 3x means 3 into minus 1 plus y equal to minus 5. So minus 3 plus y equal to minus 5. So y is equal to minus 5 plus 3, which is equal to minus 2. So x equal to 1, y equal. So the correct option from this A and D will be the D option. Yes, you can choose substitution method, or you can just go through the options, put one by one. Okay, if you're really like fast in this calculations and all, then definitely you can choose any of the method. Next problem. 19th problem. The value of the trigonometric expression sin square 30 plus cos square 45 minus 7 tan square 60. So very easy, just substitute all those values, solve, you will get the answer. Okay, so sin square 30 is 1 by 2 square. Cos square 45 is 1 upon root 2 square, and tan square 60 we know it is root 3. Okay, it is square. So this is 1 upon 4. This is 1 upon 2 minus 7 into root 3 square is 3. So which is 1 upon 4 plus 1 upon 2 minus this is 21. So see, this is 1. So let's just see the common denominator, LCM. Okay, so if you know 4 2, the LCM will be obviously 4. Okay, so here I will just write 1 because already it is, the denominator is 4. Now if I want to make this denominator as 4, what I will multiply? 2, right? So both in the numerator and the denominator I will multiply by 2. So denominator C already converted 4. So just write 2. 1 into 2 is 2. Minus here I have to multiply 4 both in the numerator and the denominator. So it will come to 21 4s are 84. Okay, normal fractions which we have studied long back. So just add this, 3 minus 84 is minus 81 by 4. Okay, so the option is yes, A option, minus 81 by 4. Okay. 20th problem. The ratio in which the point K13 divides the line segment joining the points M minus 1 7 and N 4 minus 3 internally is. Okay, so line segment M N minus 1 7 4 minus 3. Okay, K13. So we know that whenever the ratio is not given, what we take? So let the ratio be K is to 1, right? You can even take M1 is to M2. Okay, anyway you can solve, both the methods are correct. So we use here the section formula obviously. So given, for a given point, suppose kxy, okay, I will write. So what is the section formula? M1x2 plus M2x1 upon M1 plus M2, and M1y2 plus M2y1 upon M1 plus M2. Now here you have K13. Okay, so and M1 M2 is K is to 1. Okay, so K into, I will take this as x1 y1 and this is x2 y2. Okay, so what is x2 here? X2 is 4 plus M2 is 1 and x1 is minus 1 upon K plus 1. Again this is K into y2 is y2 is minus 3 plus 1 into 7 upon K plus 1. Now you need to find the value of K here, that is the ratio. So you don't need to take both the points. Okay, any one is enough, equate to any one point and you will get the answer. Okay, so I will take this x point. Okay, so 1 equal to 4K minus 1 upon K plus 1. First multiply, so K plus 1 equal to 4K minus 1. So let's just solve it. So K minus 4K is equal to minus 1 minus 1. Therefore, minus 3K equal to minus 2. Therefore, K will be equal to minus 2 upon minus 3, which is 2 by 3. So, yes, 2 is to 3. So, the option is C. Okay? Yes. So, hope you like this video. See, the most important part in your MCQ exams is that you have to first understand the concepts, okay, and second is that read the NCERT textbook. Okay, everything is there in the NCERT textbook. Just read the textbook. Okay, even the solve examples as well, study them carefully. Okay, your exercise problems, and read all the theory part. Okay, understand the concept. Okay, understand those parts. So only then you will be able to, if the concepts are clear, you will be able to solve any type of problem. Okay. So I will just, try to upload as much, problems as I can for you. Not just for Goa board, even for CBSE, I'll be uploading as many problems as I can. Okay. So thank you. And if you like this video, please share with your friends. I will continue in the next part, the remaining problems. Okay. Any suggestions, you can just, message me on Instagram, or you can mail me. Okay. All suggestions are welcome. Thank you. See you next time.